So day 4 is solving systems using substitution. So please highlight substitution at the top. And if you go through these steps, you have a algorithm or a method or a plan to solve a system of linear equations. So choose the simpler equation and express one variable in terms of the other. So how do you know which one is simpler than the other? Well, what you're looking for is any equation that has a coefficient of 1. So what do they mean by simpler equation? So look for a coefficient of 1. And if you can't find a coefficient of 1, then I don't think either one of them is simpler than the other. So if you look at the two equations underneath, which one is simpler? It would be this one here. Because you have a 1x. So we're going to be able to isolate for that 1x, and then follow step 2 and step 3. We're going to substitute the expression from step 1 into the other equation. So hence the term solving by substitution. And then you solve the single variable equation, sub that solution back into the original equation. So we have to do this for you to probably be able to visualize this. Okay, so let's take a look. That x plus 4y equals 6. I'm going to isolate for x. Now we haven't isolated for x at all. We've always been isolating for y. That's because we want to graph it. But you could isolate for either one algebraically. Are you guys okay with me moving that 4y to the other side? No issues there, right? So what we have here, this is an equation for x. That is what x equals. Whatever y is times -4 plus 6. So then what we're going to do is we're going to take this second equation, 2x minus 3y equals 1, and then watch this. This is where the magic happens. This right here is going to get substituted in right there. Since that is an expression for x, I can replace or substitute that expression into the x in the other equation. When you substitute, guys, use a bracket. So you have 2 times x. Well, what is x? X is this thing that we're going to sub in, minus 4y plus 6. Minus 3y equals 1, finish off the equation. So I'll give you a second to catch up in the notes. So we started with the first equation. We moved the 4y to the other side. This gives us an expression for x. So this expression here, minus 4y plus 6, is equivalent to x. So I can substitute it into the other equation where I see x. I use a bracket. This was x right here. And then I still have to finish off the minus 3y equals 1. Now what do you notice about this equation? It only has y. And that's the whole thing that we have to accomplish. One equation, one unknown, you can always solve that. So originally these equations, they have 2 unknowns, so you can't directly solve them one at a time. You need 2 of them to create this relationship. So this equation here is what we have to solve. So this is where it gets really algebraic. and it can be challenging for some, but hopefully you see it as a challenge and you try to meet it. Try to grow and get better. So we distribute in 2 times -4 and 2 times 6. When you distribute, the brackets are removed. Now you have to collect like terms. Minus 8y minus 3y is the same as minus 11y. Plus 12 equals 1. Now what would you do with this one? Would you move the 12 or move the 11? It doesn't actually matter, but I would move the 11. You guys, I know some of you would move the 12. Okay, but then you have to divide by a negative and make sure you switch the sign if you do it that way. So I personally would move the 11, so that means I got to move the 1. So the 11y, here I'll move it up for you guys. The 11y negative on the left goes to the right. The 1 positive on the right goes to the left, becomes negative. 12 minus 1 is 11. So it works out nice. You got 11 equals 11y, therefore y has to equal 1. So we know y is 1. Now what should I do here? Now that I know y is 1, yeah, good. You want to substitute that back here, because then we can solve for x. Because x is -4y, which we know is 1, plus 6. -4 plus 6, 2. This is the solution. 2, 1. So let's go to the next one. So if you follow the steps from the last page, which one of those equations seems simpler? Yeah, why the top one look easier? Why? Just a 1y there, right? So you're going to want to isolate for that one. That makes it a lot easier. So isolate for this one here. So what would you do with that 3x? Move it over. So you got that y is equivalent to -3x plus 3. And this expression here for y, where should I put it? Yeah, the other equation where you see y. So then when you go to do a bunch of work on the second equation, you start writing it down. You go 7x minus 2y, but y is coming from this expression up here. So instead of writing y, put a bracket and put in this expression minus 3x plus 3. And this is supposed to equal 20. And then you notice that this equation has only x. And that's what you need. You need only one variable, one equation. Okay, so this is where some of the algebra skills are going to have to come into play here. So we have 7x. What do I do with this thing next to it here? You have a -2 being multiplied by a binomial. How does that -2 affect the bracket there? It has to come in like this. Now when you multiply by a negative, what happens to the signs? So -2 minus 3 makes +6, and -2 plus 3 makes -6 when you multiply. Now you collect like terms. 7x and a 6x makes Move to 6 to the other side. And then what do? Divide by 13. How do you guys feel about that? Send the minus 6 to the other side. 20 becomes 26. And then two groups of 13 will make 26. So are we done? Well, once we have that x is 2, where does this need to go? Here. Because then you have an exact formula for y. Negative 3 times 2 plus 3. And you get negative 6 plus 3. Negative 3. So then we can write down our solution. As 2 comma negative 3. You with us there? Can I go to the next question? You guys want to try this one? All right, so we'll start with the second equation. Take the 2x to the other side. You guys got that far, right? Now this expression for y, I'm going to substitute it right here. So I end up getting a 5x minus 3y, which is negative 2x, minus 11 is 0. Did you guys get that far? Did you remember to switch the signs? Minus 3 and a minus 2 makes a plus 6. Combine like terms. Send that 11 to the other side. X is 1. How many of you guys got X is 1? Oh yeah. Impressive. Now what's so nice about substitution method is once you solve for 1, all you have to do is plug it into the other equation that you have for the other variable. Negative 2 times 1, negative 2. So then when you go to write your solution, you make sure that you include both x and y as a coordinate pair. Okay, so these ones are difficult. This is why I called them challenge questions. It's so you'll have to just bear with me here, especially the fraction work. So they have an expression for y already. Y is already isolated. So I'm going to substitute it in right here. So you have 1/2 x plus 2/3 y, where y is 1/4 x minus 5/3. And this is going to equal negative 1. So we have 1/2 x. The 2/3 is going to multiply in. So you get 2 times 1 is 2, 3 times 4 is 12. And then we got 2 times 5 is 10, and 3 times 3 is 9. So we'll go to a common denominator. We got 6 over 12x plus 2 over 12x. I'll send the 10/9 to the other side as a positive 10/9. Collect-like terms, I got 8/12 x. And we'll need a common denominator over here, so minus 9 over 9 plus 10 over 9. Reducing to lowest terms, you can divide by 4. You get 2/3 x equals negative 9 plus 10 is 1/9. And then the last step would be timesing by 3/2 on both sides. Timesing by 3/2 on both sides, we see we get 3 over 18, which is lowest terms, divide by 3, 1/6. All right, pretty nasty. I would never give that to you on a written response. But some of you in here, there's definitely a pocket of you that should challenge yourself with questions like this, and especially be doing them without any sort of calculator. I know some of you want to push yourself mathematically, and these are examples of that. Because it's all stuff that is in the curriculum from, K to 10, adding and subtracting of fractions, multiplying fractions, lowest term stuff, and then incorporating some of the new stuff with systems of equations. Oh, because it's like cross multiplying. Yeah, so it's like if this is 2/3, and if I want a 1x, I got to put a 3 there to cancel that 3, and a 2 there to cancel that 2. For exactly what I just said. So 3 cancels the 3, and 2 cancels the 2, and you get 1. Oh yeah, from 8. Oh yeah. Good. From 8/12 to 2/3 was lowest terms. Yeah, good. And then whatever you do to the left, you do to the right. So then that 1/6, we're not done. You got to put that 1/6 right here and solve for y. So you get a quarter, a sixth, minus 5/3. So you get a 24th minus 5/3. So you'd have to get a common denominator. Timesing by 8, you'd have 40/24. And you get, looks like minus 39 over 24. So just filthy. Hope I didn't make any mistakes. Yeah, very nasty. Yeah, it's a lot. But there are definitely a few of you in here that should try these as a challenge. In the textbook, you'll find questions this filthy, so there's a few of you should challenge yourself. It looks like somebody left their book up. Oh, okay. All right, let's try the one underneath. Do you guys still need those notes up above? Yeah, you still want that? Okay. Now the one question underneath here with the 3 equations, you'll never get that on my test either. So this page here is just completely for just extra material. Yeah, you can put this in lowest terms, thanks. Divided by 3, you get 13 over 8. Good, very nice. All right, so again, a 3 equation system you'll never have on your exam in Math 10. So this is just an extension. It sets you up kind of nice here because it tells you that y is equal to 3x. So you can put it right here. And then from that, you can see you have 2x minus y, which is just 2x minus 3x. You get a minus 1x equals minus quarter, so x is 4. Once you know x is 4, then you can see quite obviously that y is 12. Okay, and then once you know that x is 4, then you can go ahead and use the third equation and go 4 minus 5z is 4. And you can see that z is equal to 0. Bring the 4 to the left, the 5z to the right. 0 equals 5z. Z is 0. So actually not too bad at all. Not too bad at all.